Hey, we're live. Sorry? Yeah, went well. Here we go. Nick, my friend, can you read this out loud to me, please? What? Oh, she's my favorite student. She gets everything right. You figured that joke out yesterday or day before? Yeah, it's all good. This one, some of these questions are worded a bit vaguely, so I'm going to take multiple answers. If you're not sure if your answer is right, just wait till the end and then come lawyer with me. It's easier if I look at it. Number 1 says, describe the position of A and B using 0 as a reference point. What is the distance between them? So I'm going to say a half mark if you said A was something like +3 or 3 to the right or 3 east. A half mark if you said B was something like -3 or 3 left or 3 west or something, and then the distance between them, 1 mark if you said the distance is 6. 6 what? Well, there's no units on there, so meters, centimeters, I don't know, I just 6. Number 2 says define scalar and give an example. Okay. Half mark for the definition, half mark for the example. Definition, if you said something like magnitude only. In fact, a scalar has magnitude only. Any other weird definitions you want to try? Yep.
Direction.
Sure. And then it says, give an example. I'll rattle off the most common ones, and if you didn't use one of those, try me. Speed, distance, time, mass, volume, length, area, voltage, work, energy, power, charge. Did I miss any? Any other one? I would argue sound probably does have a direction, actually. Did you say sound?
Yeah.
You said sound as yours?
Just now.
Oh, just now, but on your sheet? Oh, shut up. Most common one was probably or time or distance. Define a vector. Two key words. Vectors have magnitude and direction. So something about direction. That gets you a half mark, and then for another half mark, you have to mention one. Velocity, displacement, force, acceleration, current, magnetic field, gravitational field, torque. Any other weird ones that you maybe thought of that I didn't say? Foot-pounds? That's actually imperial. It is also a vector. We measure torque, but we measure torque in Newton meters, not foot-pounds. Actually, no, foot-pounds is a measure of energy. Foot-pounds is actually a scalar if it's the imperial system, because that would be measuring joule meters, which is, Newton meters, which is work. So no, if you said that. Define displacement. Easiest way to define displacement, change in position. That, I'll take that for 1 mark. What else did you write? I may give you the mark. Yep.
Difference between starting point and ending point.
I'll live with that. The key idea there, key word there is difference. Anything else?
Displacement between an object's initial position and final position.
Using the word displacement to define the word displacement is called circular reasoning. That's like saying I'm dumb because I'm stupid. It just goes in a circle and a circle. So if you use the word displacement in the definition of the word displacement, I'm going to be fussy and say no.
Distance from initial point.
Because you use the word distance, no, because they are two different things. Any others? Now, I'm not going to ask you for a bunch of definition-y stuff, but it's good for us on the test itself, but it's good to think about. Yeah?
How far you are from your original point.
I'll live with that. Is mine 3 words and shorter?
Yeah.
And it uses change in, which eventually, as soon as you see change in, you'll know that that means final minus initial. It's a good physics definition. Now we're doing some math. Number 5, suppose I run 100 meters in 9.8 seconds, calculate my average velocity in meters per second and kilometers per hour. It says show work and report to correct sig figs. I'm not going to freak out on sig figs. I will freak out on units, though. If you're missing units, you're going to lose a half mark each time. First of all, I'm going to break this up kind of into three things. There is no acceleration mentioned in this equation. They're asking you to find velocity. Really, what they're asking you to do is this. If you wrote that down and couldn't do anything else, that's going to get you 1 mark. Now, if you didn't write that down, but you get the right answers, you're going to get this mark anyhow, because I'll assume that if you got the right answers, Matt, that you would have written down the formula. Right answer number 1 for meters per second, the velocity is going to be 100 divided by 9, come on, pen, 0.8. And I get 10.2 meters per second. If you said 10 meters per second for the sig figs, I'm good with that. Although technically you should write that, because if you just wrote that, how many sig figs is that? Only 1. I'm not going to take marks off, but I will take a half mark off if you missed the units. So 1 mark for that. Then we want to go to kilometers per hour. How do I go to kilometers per hour if I'm in meters per second? Times by 3.6. I'm going to use the number on my calculator. 36.7 kilometers per hour, or 37 kilometers per hour if you went to 2 sig figs. So 1 mark for that. And again, if you got both of those right, but you didn't write somewhere v equals dt, you get the mark. What I do want you to realize is if you don't know how to do the math, but Janaya, you know how to start the question, that's worth something as far as I'm concerned. If you can identify what our approach should be to start out with, I'm good with that. Number 6, suppose I run on an average velocity of that for that. How far will I run? They want me to find a distance. D equals VT. You get 1 whole mark if I see that somewhere. Again, if you don't write that, Roy, but you get the right answer, you're going to get 2 out of 2. It's going to be, oh, good gosh, 6.3 times 45. 283.5. And now I'll do my sig figs. I guess technically I would go to 2 sig figs. So 280 units, meters. So 1 mark, 1 mark, half mark off if no units. I'll live with that, but sure. I'm not being fussy on sig figs this year. Did you? No, as long as you get the right answer, I assume you had the formula right. What I do want you to realize, Nick, what drives me crazy is don't you ever, ever, ever on a test leave a question blank. If you don't know how to do it, I'm willing to bet you could at least figure out where you would start with and what equation. Have I been teaching you kind of a DFIC approach of listing data and finding the formula? Hey, maybe I had that in mind when I was teaching you that approach. Number 7, how long will it take me? They want me to find time. I think I'm going to go like this. Right. By the way, all of these are really coming out of this equation here. But on this quiz, acceleration was 0, so you're really using d equals vt. This is why in Science 10, you just did that. Triangle. Jeez. 12.3 divided by 2.3. 12.3 divided by 2.3. I get 5.3478. I'll call that 5.35 time seconds. Or if we go to correct sig figs, I guess technically to 2 sig figs, which would not be 5.4. It's actually 5.3 if I go to 2 sig figs. Anyways, 1 mark for the answer, 1 mark for the equation. However, if you got the answer right, you get 2 out of 2. What does the slope of a position versus time graph represent? Velocity. One mark. Number 9, the graph below is the position time graph for a short car trip. Find the average velocity for each part of the trip. How many parts of the graph are there? 3. How many marks is this one worth? I guess 1 mark for each section would make sense. I'll call this section A, B, and C just to be organized. So section A, it's a distance versus time graph. What is that section A telling you? What's the, how can I find the average velocity? Sorry, that's what I should have. Well, how can I find the average velocity? Yeah.
It's going up 5 meters in 1 second.
Oh, did you just do a rise over a run? Yeah, so the rise is 5, the run is 1. Section A, average velocity, 5 meters per second. 1 mark for that. Section B, average velocity, the rise is -1, because we went down 1. The run is between 1 and 3, 2. So -0.5 or -0.5 meters per second. If you left it as -0.5, that's fine. Section C, it looks like the rise is -4, yes? And the run is 2. Oh, I think it's -2 meters per second. So 1 mark for each of those. 5 meters per second, -0.5 or -0.5 meters per second, and -2 meters per second. Oh, and for what it's worth, where did I end up? Looks like back where I started from. My displacement is 0. Number 10, consider the following velocity time graph. Describe the motion. I'll call this section A, section B, and section C, just to be organized race. So section A, what can you tell me about that section? What's going on? So if you said speeds up, or the fancy schmancy word, accelerating, that'll get you 1 mark. If you were really a nerd and you found the velocity by going rise over run, because the slope, found the acceleration, because the slope of a velocity versus time graph is the acceleration, I think you end up with an acceleration of 9 over 5 or 1.8 meters per second squared. If you said that, that would get you the 1 mark too. What's happening in section B? For section A or B or A? If you said accelerating uniformly, sure. What's happening in section B? I'm going to suggest to you not accelerating uniformly. Yeah. Or you could have said A is 0. C. What's happening here? Slowing down. So if you said slowing down, what's the fancy schmancy physics word for slowing down? What's the opposite of accelerating? Yeah, if you wrote decelerating, that would be good as well. I think there's 2 C. Is there 2 C's or 1 C in decelerating? 1 C, decelerating. Or if you were clever and you found the rise over run, and I think again you get -9 over 5. I think you get -1.8 meters per second squared. If you said coming to a stop, because it does look like as though it comes to a stop right at time equals 15 seconds. Any other weird stuff? How many marks is this worth? 2. How many things are there? 3. How about a half mark off for each one of those that's wrong? But if you get all 3 wrong, you get 0. You can't get a half mark just for writing nothing, writing anything. I don't know. Number 11, sketch the graphs. Greg, 11A, what type of a graph is that? What versus what? Distance versus time. So what do they want me to draw? What versus what? What's the right-hand graph? So the real question is, how can I get the velocity from a distance time graph or a position time graph? How can I? How do I get the velocity from a displacement time graph, folks? Aaron? Slope. It's a slope. So this graph A has a positive unchanging slope. That means a positive unchanging velocity. I would look for a graph that was a horizontal line and above 0. I don't care how high your line is, Janaya, somewhere there. Could be higher, could be lower, don't care, because I didn't give you any numbers, but definitely it's a horizontal line. 1 mark. Cole, what's happening in graph B? I would look for then, and you'd have to make it really thick just so it stood out. I would look for a line right there, horizontal line of 0, high. Ooh, what's happening in graph C? Nick? Sorry? Yeah, it is. You know how I know? Because right now it's this steep, that fast. Now it's this steep, that fast. Now it's this steep, that fast. In fact, yeah, it's getting steeper. It's getting faster. It's accelerating. So I would look for a line that looked probably like that. Now, you could draw it shallower, you could draw it steeper, but I would look for a line that was increasing in height, speeding up. So if you can give yourself a clear score on your take-home quiz out of 21, and if you become lawyer with me, now is the time.